Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will continue our topic in material science and engineering. So today you will learn about the metals and how the metals to be processed to become an alloys. So today you will learn on how metal alloys are classified and what are their application and how the fabrication techniques of for metals and what the heat treatment procedures to improve the mechanical properties for ferrous and non-ferrous alloy. So you will first understand what is ferrous and non-ferrous, what is metals and what is alloys, and how the fabrication technique for that particular materials. So this is a classification of metals. So metals alloy can be classified into two, which is ferrous and non-ferrous. So we want to learn about ferrous materials. So ferrous is the metals that can be classified into two, which is steels and cast iron. So what is ferrous? Ferrous is a metals that contain carbon. Okay, ferrous contain carbon. Non-ferrous, it doesn't contain carbon. Okay, so the example of ferrous is steel, because steel, you know that it contain iron and carbon, so we call it steel instead of iron. Okay, and also we have cast iron. Cast iron is a iron that have 3 to 4.58% carbon. Okay, so the cast iron have more carbon than steel, because steel have less carbon, which is less than 1.48% carbon. So if you go to the phase diagram, okay, to the diagram, you can see that this is the x-axis is a composition of carbon. So less than 1.4, which is here, okay, which is here, is steel. More than more than 3.3 to 3 to 4.5, here to here, it's cast iron. So from here to here, the microstructure will be ferrite, graphite, and cementite. Okay, so based from this phase diagram, you also can classify where is the steels, and also where is the composition of cast iron. Okay, so here we will learn more about steel. So before this, in your life, in your daily life, before, I don't know if you know or not. Okay, let's just consider that you don't know. Okay, what is steel can be classified into. Okay, so steel can be classified into low alloy and high alloy. So low alloy steels, um, low alloy steel is a steel that have less than 1.48% carbon. Okay, it can be classified based on their carbon content. So low carbon, medium carbon, or high carbon. So low carbon is where the steel has less than 0.25. We call it plain steel, or HSLA, which can be used to make bridges, towers, pressure vessel. Okay, and the plain steel, basically they use for auto structure or a sheet. Okay, and for medium carbon steel, either it is plain or heat treatable. Okay, it can be for used for crankshaft, bolt, hammer, blades. Okay, and if you heat treated it, okay, treated it while you add more chromium, nickel, or molybdenum. Okay, for example, is steel 4340. You can make it as gears. Okay, or piston. And for high carbon steel, basically used for tool because we need high strength materials such as drills, saw, dies. So uh, you need high hardness or high strength materials, okay, to make drills, okay. And for high alloy steels, either it's made for tool steels or stainless steel. So you have been heard about stainless steel, right? So stainless steel is the steel that um, have uh, high alloy content. What does it mean it's high alloy content? Because they have more addition of materials. For example, chromium, nickel, molybdenum. There's a more element of element of metal inside. Well, that's what we call stainless steels. So stainless steels, basically they have high temperature application. You can use it at high temperature in turbine, in for furnaces, and it has a very corrosive resistant materials. Okay, you can use it at a corrosive temperature. So that is a stainless steel. So more from the low carbon to high carbon, you can see that the strength increase. For of course the cost increase because you put a more addition of metals. And if increasing strength, so I said before, if you increase strength, the ductility will be decreased. So it will sacrifice the ductility of that material if you increase the strength. So this is the process on refinement of steel from ore. Okay, uh, we they do it in a blast furnace. Yeah, so we call this one is a blast furnace. You can see this furnace is very massive. Yeah, uh, where you put iron ore, you put coke, you put limestone. Okay? They have some process that need to be undergo to form steel. Okay, first you have to generate the heat is generated. So carbon plus oxygen form carbon oxide, and iron ore will be undergo reduction process to form a metals, and then it will be purified eh, to get a molten iron. So this is the process to get the iron. So now let's go to we want to learn about ferrous alloy. So what is ferrous alloy? Ferrous alloy is iron based alloy. For example, steel, cast iron. So how you grade or how you read the steels based on their nomenclature. Okay, so if you can see that they said 10XX, this means that it's plain carbon steel. 11XX is plain carbon steel that resulfurize. They sulfurize it for easy machinability, easy to machine. And yeah, you can see that how the steel is nomenclatured to classify one from the others. Okay, so next we go to cast iron. Cast iron is a alloy, ferrous alloy that have more than 2.1% carbon. It is commonly 3 to the range is 3 to 4.5 carbon. That have low melting point, means that it's easy to cast. You means that you don't have to melt it at high temperature to cast it. Okay, and it's generally brittle because of the high carbon content. And how to get it? You have to decompose cementite to ferrite and graphite. So now we want to learn about type of cast iron. We have gray iron and ductile iron. So if you can see this micrograph, it is a gray iron that have graphite flakes. You can see that the flakes image here. But gray iron has a weak and brittle in tension, but if you do compression, it's much more stronger. Okay, and it has excellent vibrational dampening and also have a resistance to wear. Okay, wear failure. Okay, then ductile iron. Okay, if you can see the image of ductile iron, it looks like sphere sphere nodules. We can, yeah, they have a graphite as nodules, and it is not flakes. Okay, if it is ductile, it's not like this. This is just like flakes, but it is much more like a nodule. And ductile iron usually add magnesium or cesium. Okay, and the matrix often perlite. Okay, the matrix is the majority of the phase is perlite, and it's much stronger but less ductile. Okay, so that is a ductile iron. Okay, then now the cast iron also have a white iron. We have white iron, which consists of less than 1% of silicon, and it is has a perlite and cementite structures. And yeah, it's very hard and brittle. Okay, white iron is very hard and brittle. And malleable iron, okay, as the name is malleable, it is reasonable, it is strong and ductile because it's malleable, can be it is yeah, it is ductile, yeah, and in heat, it is heat treated at 800 to 900. The it is from white iron. Actually, the malleable iron is from white iron, but you heat treated it at 800 to 900, and then you will get a malleable iron. Okay, and you can see the image is like a rosette. The graphite look like a rosette, and it is strong but and ductile as well. Okay, so the last one is a compacted graphite iron. Okay, it is also a type of cast iron. It has high thermal conductivity, good thermal shock, and at high temperature, it has a low oxidation. So this is very good because usually iron have a very high oxidation at high temperature, so it is easily to break. But graphite iron has a lower oxidation if you use it at high temperature. So this is how the cast iron is product is made. Okay, so it is at this region, the cast iron, from what 3 to 4.5, right? You can check it back, but this is how the cast iron is made. Okay, okay, I think you can read by yourself if you cool it fast. Okay, as I said, you will get a white cast iron. If you cool it moderate, you will get perlite and gray cast iron. If you slowly cool, you get austenite and gray cast iron. Okay. So what is the limitation of the ferrous alloy? Usually they have high density, it's very high weight. It has low electrical conductivities, cannot conduct electric, and it also have a poor corrosion resistance. It's easy to corrode. Okay, so now we go to non-ferrous alloy. So non-ferrous alloys basically is a copper alloy, means that um, the majority of the composition is from copper. Okay, for example, brass, bronze, copper, beryllium. Okay, and titanium alloys means that majority is titanium, and that titanium alloy has low density. Okay, is low weight. Okay, noble materials, silver, gold or platinum, or refractory materials, also non-ferrous alloys, magnesium alloys, and also aluminum alloys. The alloys that contain the majority of the component is not iron, we call it non-ferrous alloy. So basically this alloy has their own properties. Okay, so when, for example, refractory metals means that metals that can that has high melting temperature. Okay, and magnesium alloy, basically they are very low density, very lightweight, so you can use it for aircraft or missile.